De har precis fått loss filmen. Ja, det är jättebra. Ja, nej. Ja, vi kan prata om det. Nej. Ja, nej, men alltså det är mycket. Såvida inte det händer något där i gängen. Det tror jag. Så det är kanske...
Jag kommer inte säga... Det här är angående gängkriminalitet. Ja, precis. Ja. Kanske fler som har... Ja. Nej, men det är ju...
skivor i men jag vet. Jag antar att de testar dem orden eller? Ja. 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 Ja, 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 men absolut. Jo, det har varit mycket.
Här. Kan du gå upp?
Ladies and gentlemen, good morning and welcome to Nobel Forum for the announcement of this year's Nobel Prize in Physiology or Medicine. My name is Thomas Perlman and I'm the Secretary General of the Nobel Assembly. I will first read the announcement in Swedish, followed by English. We will then present the background to the prize and open up for questions. Nobelförsamlingen vid Karolinska institutet har idag beslutat att Nobelpriset i fysiologi eller medicin år 2023 ska delas lika mellan Katalin Karikó och Drew Weissman för deras upptäckter rörande nukleosidbasmodifieringar som möjliggjorde utveckling av effektiva mRNA-vacciner mot covid-19. The Nobel Assembly at Karolinska Institute has today decided to award the 2023 Nobel Prize in Physiology or Medicine jointly to Katalin Karikó and Drew Weissman for their discoveries concerning nucleoside-based modifications that enable the development of effective mRNA vaccines against COVID-19. Here are the two laureates. Katalin Karikó was born in 1955 in Szolnok in Hungary. She performed her prize-winning studies at the University of Pennsylvania in Philadelphia in the United States. She is currently a professor at Szeged's University in Hungary and is also an adjunct professor at the University of Pennsylvania. Drew Weissman was born in 1959 in Lexington, Massachusetts in the United States. He performed his prize-winning research together with Katalin Karikó at the University of Pennsylvania, where he is still active as a professor. I will now turn to Professor Richard Sandberg, member of the Nobel Committee, who will now describe the discovery. Please, Richard.
In today's interconnected society, the risk of new pandemics is greater than ever before. When the virus SARS-CoV-2 emerged in late 2019, it rapidly spread across the globe and developed into the devastating COVID-19 pandemic. During the viral infection, the immune system recognizes viral components as foreign, and they induce antiviral immune responses mediated through cells and antibodies. However, this takes time, and meanwhile the person can develop serious disease. Vaccination strategies have been developed with the purpose of inducing antiviral immune responses that will protect against future infections. For a long time, weakened or inactivated viruses have been used as vaccines. Vaccination programs have been very successful in mitigating many life-threatening diseases, including polio, measles, and yellow fever. With advances in molecular biology, targeted vaccination strategies became feasible. By isolating genetic information from the virus, specific viral proteins could be produced and used as vaccines. Examples are highly effective vaccines against the hepatitis B virus and the human papillomavirus. More recently, harmless viral vectors have been used to deliver viral DNA fragments into human cells to make viral proteins and induce an immune response. Examples are the recently developed Ebola vaccines. The targeted strategies have the advantage of not requiring whole viruses, but still they rely on resource-intensive cell culturing for vaccine production. Researchers have therefore long been attracted to the idea of using messenger RNA or mRNA for clinical applications, where the mRNA is used as a template for protein synthesis. The production of mRNA does not require large-scale cell culturing, and future vaccines based on mRNA had the potential to become scalable, fast, and flexible. In fact, major advances were made in the last decades. Researchers showed already 40 years ago that large amounts of mRNA can be produced without cells, for example using the T7 in vitro transcription system. Moreover, progress was being made in delivering mRNA into cells using different forms of lipid carriers. But there was a major obstacle to development of mRNA-based clinical applications. When in vitro produced mRNA was delivered into cells, it resulted in low protein amounts, and additionally, it triggered an inflammatory cytokine response. This year's Nobel laureates, Katalin Karikó and Drew Weissman, started working together at the University of Pennsylvania, bringing with them highly complementary expertise. Karikó had a background in RNA biochemistry and a strong vision of RNA-based therapeutics. Weissman had a background in immunology, working with dendritic cells and their role in immune surveillance and vaccination. It was clear to them that in vitro produced mRNA must somehow differ from the mRNA made in human cells. Delivering in vitro produced mRNA into dendritic cells induced the inflammatory cytokine response, whereas the delivery of human mRNA did not. Using bacterial mRNA, shown on the right side, did also trigger the inflammatory response. Having explored several potential differences in the mRNA, they became interested in nucleoside-based modifications. RNA contains 4 bases, often abbreviated as A, U, G, and C. However, these bases can get further chemically modified within our cells. It was becoming appreciated that base modifications were more prevalent in human RNA compared to RNA in bacteria. Could the lack of base modifications in mRNA produced in vitro be the critical factor that leads to inflammatory response? In a series of carefully constructed experiments, Karikó and Weissman used the T7 in vitro system to produce mRNA with various nucleoside-based modifications. Each type of produced mRNA separately introduced into dendritic cells while monitoring the TNF-alpha levels, an important inflammatory cytokine. They discovered that mRNA produced with specific base modifications could almost completely abolish TNF-alpha secretion. In particular, modifications to the uridines, highlighted on the right side in orange, made a large difference. One of the most effective modified bases was pseudouridine, which is a naturally occurring uridine modification. Whereas in vitro produced mRNA triggered toll-like receptor activation, leading to inflammatory cytokines, mRNA made with pseudouridine did not. Karikó and Weissman published their breakthrough discovery in 2005, 15 years before the COVID-19 pandemic. Realizing the importance of their discovery, they next demonstrated that base-modified mRNA resulted in higher protein expression in target cells, both in cell culture and in animals. More protein was made from each delivered mRNA molecule, and the laureates carefully dissected the cellular pathways involved. Karikó and Weissman made fundamental discoveries of the importance of base modifications in mRNA, which eliminated a major obstacle to mRNA-based clinical applications. Building upon this mRNA technology, as well as research by others on stabilized spike protein and mRNA delivery using lipid nanoparticles, 2 highly effective mRNA vaccines against COVID-19 were developed and approved in record time. Importantly, the 2 mRNA vaccines had complete substitution of uridines for a pseudouridine variant in the sequence coding for the spike protein. mRNA vaccines, together with other COVID-19 vaccines, have been administered over 13 billion times. Together they have saved millions of lives, prevented severe COVID-19, reduced the overall disease burden, and enabled societies to open up again. The successful mRNA vaccines against COVID-19 have had a tremendous impact on the interest in mRNA-based technologies. mRNA technologies are now being used to develop vaccines against other infections. The technology may also be used for therapeutic protein delivery and cancer treatment in the hope of further improving human health. Here are the 2 Nobel laureates again. So this year's Nobel Prize recognizes their basic science discovery that fundamentally changed our understanding of how mRNA interacts with the immune system and had a major impact on society during the recent pandemic.
Thank you, Richard. I would like to open up for questions. We'll of course continue with interviews outside, but if there are any questions. Yes?
Have you managed to contact the winner? Who did you speak to, and what was their response to this announcement today?
Yeah, I was fortunately I was able to reach both of them, they were very happy. It was wonderful to talk to them. This year I actually asked if they were surprised, because I suspected they maybe would not be having received many prizes, but Katalin Karikó explained that she was so overwhelmed, and also put it in context with her situation as a scientist for many years. 10 years ago she told me that she was terminated from her current position and had to move to Germany for another position, and without her family and so forth. So it's been a dramatic change in her circumstances, and she acknowledged that, and she was great to talk to her and very happy. Drew Weissman as well. I mean, it was wonderful to talk to him. He was overwhelmed and enormously grateful for this award. So yes, I got hold of them. Drew Weissman just a few minutes before coming down here. Yes.
Hello. Yeah, I'm Sufficient Axelson from the Green Post. I ask a maybe inconvenient question and need your further explanation. Do you really think that it's the vaccine and this COVID-19 pandemic? Thank you.
With this question, I would like to introduce our panel here. So I'll first introduce those who are sitting here. To the far right is Olle Kempe, Professor Olle Kempe, who's Vice Chair of the Nobel Committee. And then it's our Chair of the Nobel Committee, Professor Gunilla Carlsson-Hedestam, and I already introduced Professor Richard Sandberg. Perhaps, Gunilla, could you respond to that question?
Yes, it's of course a very reasonable question. As I think hasn't escaped anyone, this virus is still circulating, and there's now many variants that have spread, and this is of course how viruses behave. So once it has achieved that sort of level of spread, it's very difficult to stop it completely. But what's important here, I think, is that vaccines could be developed so fast, and this was, as we just heard, largely due to improvements in the technology and this basic discovery that allowed this. So I think in terms of saving lives, especially in the early phase of the pandemic, it was very important. Now most people have developed some level of immunity as a result of combined exposures to the virus and to multiple vaccinations. So we're not in, this situation is not as dire as it was a few years ago.
Yes? Yeah. You'll get the microphone.
Thank you. This is Sunny Life Weekly from China. So my question is, considering the fast approval of mRNA-based vaccine against COVID-19, what impact can this year's prize have on the authorities to make decisions in the future for mRNA-based vaccine development? And another question is, do you consider this year's prize as a powerful strike back for the anti-vaccine movement and also for vaccine hesitation?
Olle Kempe, could you respond to those questions?
If I start with the latter part of your question, does this affect the anti-vaxxers and people who are hesitant? Anti-vaxxers, I don't know if they will change in any way, but I think giving a Nobel Prize for this COVID-19 vaccine may make hesitant people take the vaccine and be sure that it's very efficient and it's safe. Now we have 30 million tests being done all over the world on people who's not experienced the disease previously, and we know it's a very safe and very efficient vaccine.
The other question was if it will our decision to award
I think if the FDA and EMA will be faster in a situation like this, I think they made the right decision to be very fast. In other cases, it may be wise to be a bit slower.
Okay. Any additional question? Here's one. Yes.
Hello, this is Caixin Media from China, and with the mRNA, we don't know the long-term effect yet. So, do you have any concern over that?
Richard, would you like to respond to that question?
Yes. Of course, mRNA vaccines have only been given for a certain amount of time, which begs your question. Having said that, of course, the mRNA vaccine that is given is very transient, and the fact that 30 billion people have gotten the virus, vaccine virus, and the amount of side effects noted to date is extremely limited. So I don't think it's a major concern.
Anyone else want to add to that? That's fine. Yes.
Well, it can't be integrated into the nucleus, into the DNA, and that's, a safety precaution. The adverse effects that's been noted is mostly mild myocarditis or perimyocarditis, mainly affecting young males, but that normally resolves without any long-term effects.
And maybe one could also add that the consequences of having COVID-19 can definitely have long-term health effects, as we know. So one always needs to relate the very minor effects of the vaccine to the severe risks of actually getting the disease. Yes?
Thank you, David Keaton, Associated Press. Obviously, throughout the pandemic, COVID-19 pandemic, we saw a very strong anti-vax movement, specifically targeting these new technology vaccines. As a scientific body, as scientists, what must this medical community do to try and breach this gap of trust between the wider audience, the wider public, and the scientific community to convince people that these are indeed safe.
Yeah.
I think continuing to communicate how vaccines work, and for example, in the case of COVID-19, people felt that the vaccines were produced or developed very quickly. And that's true, because there was a huge need for that. But what these accelerated clinical trials did was not to remove any safety step. It was running things in parallel instead of sequentially. So there was no compromise in terms of the safety measures. And maybe that's not always understood. So, of course, communicating how it's done and all of the decades of basic research that's behind this kind of work, that's also not always appreciated by the public. But I think hopefully this prize can help highlight some of that, because this work has been going on since the 1990s.
There is one more here.
Hello, thank you. I'm from Chinese Nordic Time, and I'm happy. Actually, last year I'm sitting here and I asked the same question. So, well, mRNA vaccine will win the prize, but this year it got a well-deserved prize. So I think everyone's happy with this. So the first question is about mRNA vaccine. So, is there any other applications for mRNA vaccine in other diseases like cancer or like infectious diseases like this? So, could you introduce a bit for the audience? The second one is about long COVID, because I think now long COVID impact is really important point for the society. So could you also let us know?
Maybe I'll ask Gunilla to answer the first part of the question, and Olle the latter part.
Okay, so regarding other applications, yes, there's really quite a lot going on right now, and this is only going to increase most likely because we now have this increased safety data on the platform in general. But the main other applications I think we're going to see is, of course, many other vaccines against infections, particularly perhaps for flu, where we need updated vaccines. And that is one of the great advantages with this platform, is that it's flexible and fast, so one can update the vaccine if there's new virus variants coming, which we know happens all the time for flu. Other applications that are really there's going to be a lot of exciting findings, I think, coming out, and that's already started, is in terms of therapeutic cancer vaccines. So those are not preventative but therapeutic vaccines, and they can either be done in a personalized manner or in a more general manner. Cancer is, of course, a very difficult disease, and it's in fact many different diseases, but cancer vaccines might very well benefit from this platform. And thirdly, there is many experiments and actually already clinical trials going on to deliver therapeutic proteins. And that can be replacing a defective enzyme, or it can be introducing an immunomodulatory protein. So in that sense, there is quite a lot of work that we will see, I think, applied to a variety of diseases.
So for the second part of your question, long COVID, well, first of all, vaccination prevents you from getting long COVID. Then long COVID is a spectrum of different diseases, which ranging from the myocarditis that is usually much more prevalent if you get the COVID infection than from the vaccination, and it's also usually more severe. To long COVID, that is something we still don't understand the etiology of, and there is quite a lot of research ongoing on that.
Yes, I'd like to ask you, Thomas, about Katalin Kariko's personal circumstances. You said that she had to leave her job, and could you just give me some more details about what happened to her and what the prize means?
Yeah, I should say that I can only convey, and she essentially only told me what she has been telling in other interviews. And she's been explaining that her position, she never had a tenured position at University of Pennsylvania, and in 2013 it appeared as, from what she's saying, that it was hard to continue under those circumstances. She got a very senior position as vice president in a company, BioNTech, that later went on to produce make one of the vaccines. So she was not out of job in that way, but away from her family. She never received an R01 grant from NIH, which is a clear sign that she struggled and didn't get recognition for the importance of her vision. Because what was clear was that this is an extraordinary and unusual scientist who was very passionate about this idea of mRNA and using it therapeutically. And she resisted any temptation to sort of go away from that path and do something maybe easier, and maybe tell something about the funding situation, also being a female and being a foreigner and so forth. I'm sure it didn't make things easier, but she has not been complaining. She has also explained how happy she's been, and she did she was making progress through the years. So it was not that she was inactive, but she didn't get strong support, not the tenure and the support to build up a big group. Instead, of course, she found very fruitful collaborations on the way. Yes. Is there anything more? I know several, so okay. So I think then, I know several are eager to have interviews. So I think we'll close this part of the press conference right now. Thank you so much for coming, and apologies for the short delay. Thank you.
Jag kan bära den. Jag lägger dem här.